So today we are going to start with inverse Laplace transforms. Inverse Laplace transforms. Inverse Laplace transforms, it's just the inverse of what we have found till now. So that is, we know that the Laplace transform of 1 is 1 by s. Exactly in the similar manner, so the inverse Laplace transform of by s is given as 1. So the way we have defined the derivative is nothing but derivative of x is 1. Of 1 is x. So exactly the opposite of it. Now, Laplace transform of e power at as 1 by s, or the L inverse of 1 by s minus a is nothing but e power at. This is how you can define. So Laplace transform of t power n is given as n factorial divided by s power n plus 1. Or in other words, this is L inverse of 1 by s power n plus 1 or s power n given as, so 1 by s power n factorial comes down, and here for n plus 1 it is n factorial, for n it is n minus 1 factorial into t power n minus 1. T power n here. Got it? So this is how actually you will define the Laplace transform. Now actually this is for the known functions. Similarly, the Laplace transform of sin at is given as a by s square plus a square. Now it implies L inverse of a, so 1 by s square plus a square is nothing but 1 by a times of sin at. So Laplace transform of cos at is given as s by s square plus a square. It implies L inverse of, so s by s square plus a square, right? So L inverse of s by s square plus a square is given as cos at. This is how actually you will be finding the Laplace transforms for some of the most simplest functions. But what if there are complex functions? For that actually we will be adopting different methods. Now first you note down this. I am going to give you the other methods that we are going to use. The same principles whatever you have used. That is, in yesterday's class I have proved some of the basic theorems related to Laplace transform. Now exactly those theorems only we will be using back to find out even the inverse Laplace transform in the inverse method. Got it? So that is the same thing. So if you multiply with t, what we have done for s, exactly if you do the same thing for s, you will have to find the Laplace transform of t into f of t. So this is the counter method. So exactly the same principles whatever we have used yesterday, those principles only we are using for finding out the complicated Laplace transforms inverse. Got it? So you can note down this. Let me know once you note it down. Find the inverse transform of s square minus 3s plus 4. Find L inverse of s square minus 3s plus 4 divided by s cube. So what is the Laplace transform inverse of it? How do you find the inverse for it? So this is straightforward, simple. This is L inverse of So s square by s cube minus 3s by s cube plus 4 by s cube. This is L inverse of 1 by s minus 3 by s square plus 4 by s cube. So L inverse of 1 by s is 1 minus 3 times of L inverse of 1 by s square is t and plus 4 times of L inverse of 1 by s cube is nothing but t square by 2 factorial. So 2 factorial is 2. So this is the answer. 1 minus 3t plus 2t square is the answer. Got it? What is the L inverse of s plus 2 by s square minus 4s plus 13? Can you find the L inverse of it? Anybody got the answer for it? So that's not the complete answer. So let me solve this. See this L inverse of this can be written as, the denominator can be written as s minus 2 whole square. So minus 2 square, that is minus 4 plus 13. And numerator can be written as s minus 2 plus 2 plus 2. I hope you understood. I have subtracted 2 and I have added 2. Then this can be written as L inverse of s minus 2 plus 4 divided by s minus 2 whole square minus 4 plus 13 is nothing but 9. That is nothing but 3 square. So this is L inverse of s minus 2 divided by s minus 2 whole square plus 3 square plus 4 times of s minus 2 whole square plus 3 square. So for this we need to be finding out the L inverse. Now in this actually, if you apply the first shifting property, e power 2t you can take it out. Even here also e power 2t you can take it out. This is e power 2t times of L inverse s by s square plus 3 square plus 4 by s square plus 3 square. Now this is straightforward. So that is e power 2t. So this is cos 3t plus 4 times of sin 3t. The answer. Yeah, it's correct. 4 by 3. Got it? So now actually, with the method of partial fractions, find the Laplace transform inverse of, I hope you noted down. Find L inverse of 2s square minus 6x plus 5 divided by s cube minus 6x square plus 11s minus 6. Find the L inverse of it. Now, as long as the numerator highest power is lesser than the denominator highest power, this easily you can be able to divide into the partial fractions. Now, the factors of this is, so this is one of the most famous method. So that is, it is the factors multiplication of s minus 1 into s minus 2 into s minus 3. So this is the standard form of it. So this is L inverse of 2s square minus 6s plus 5 divided by s minus 1 into s minus 2 into s minus 3. So for this actually you can divide into a by s minus 1 plus b by s minus 2 plus c by s minus 3. So for this you can find out the L inverse value. So if you want to find out the a value, what you can do is you have to identify one of the pole making 0, that is s minus 1 is equal to 0 or s is equal to 1. Then close that s minus 1. Substitute s is equal to 1 in the entire equation. That is 2 minus 6 plus 5. So 2 minus 6 plus 5 is nothing but plus 1 divided by, so 1 minus 2, 1 minus 3. So this is nothing but 2. So that is 2 times of s minus 1 plus, now you make s is equal to 2 by closing this. If I make s is equal to 2, this is 2 minus 1 is plus 1, 2 minus 3 is minus 1. So denominator is minus 1 and the numerator is, so 2 into s square. So s square is 4, 4 into 2 is 8 minus 12, 8 minus 12 is minus 4 plus 5. So that is plus 1, plus 1 divided by minus 1, this is nothing but minus 1 divided by s minus 2. Similarly, to identify c value, close s minus 3 and then substitute s is equal to 3. So this is 3 minus 1 is 2, 3 minus 2 is 1. So this is denominator is 2 and this is 2 into 3 square, that is 18 minus 18, 0 plus 5 divided by 2 into s minus 3. So for this actually you can find out the L inverse value. L inverse is nothing but 1 minus 1 by 2 into e power t minus e power 2t plus 5 by 2 times of e power 3t. This is the answer. This is correct. See this. I have used a shortcut method to identify these ABC values. But the standard method of partial fractions is, first you will write it in this format, find out the LCM of it, and then simplify the LCM and equate the corresponding terms onto the numerator. So that is the method of finding out the coefficients, that is the ABC values in the partial fractions. But there is a simpler method, as long as if you are able to divide into the simple factors like this, then you can close s minus 1 by and then close this value and then substitute, which will make the s value being 0 here. So s minus 1 is equal to 0. If you make s minus 1 is equal to 0, then s is equal to 1 is the value which will make this part 0. So close that and substitute the s value, which will make this factor 0. That is s is equal to 1. You will get the value of this a, that is s minus 1 numerator. Similarly, if you want to find out the b value, then close this factor in this s minus 2 and then substitute s is equal to 2. You are going to get the value of b. Similarly, close s minus 3 and then substitute s is equal to 3. You are going to get the value of c. Got it? Understood or not? Ravindra? So once you got the values, then you simply find out the L inverse. This you will be able to know. So 1 by s minus 1 L inverse is e power t. 1 by s minus 2 L inverse is e power 2t. 1 by s minus 3 L inverse is e power 3t. The rest of the values are constants. Clear? Now the standard method of L inverse with the help of partial fractions. Now you have to do it if it is a complex factor. That is, if you are not able to divide into the factor of s minus 1 into s minus 2 like that. So I will give you one more example in the similar manner. So find out the L inverse of it. Find the L inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. Find the L inverse of it. Anybody got the answer for it? So the way we divide the partial fractions here in this case is, one is a by s minus 1 plus bs plus c divided by s square plus 2s plus 5. This is how you will write it. Why? Because you cannot factorize this s square plus 2s plus 5 into the normal factors, that is only the real factors. So in such cases, if you are not able to divide into factors, you will keep it as it is, but the numerator you will write as bs plus c, that is one factor or one value will definitely have s, another value will be a constant. If it is a simple factor, then it will be simply a, but if it is a complex factor, then it will be in this format. Got it? Understood or not? Now, once you find out this a value, you can straight away find it out. The a value is nothing but keeping s is equal to 1, and by closing this you are going to get the value of a, that is 5 plus 3 divided by 1 plus 2 plus 5. So 5 plus 3 is 8, and denominator is also 8, then the value is 1. So that is 1 by s minus 1 plus bs plus c divided by s square plus 2s plus 5, and this value is equal to 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. So if you simplify on the right hand side, this is s square plus 2s plus 5 plus s minus 1 times of bs plus c. So if you multiply with s, this is bs square plus cs, with minus 1 if you multiply it, minus bs minus c. So this value divided by s minus 1 into s square plus 2s plus 5. So this denominator will cancel out, and 5s plus 3 should be equal to the simplified form of it. 5s plus 3 is equal to, the simplified form is, this is 1 s square, this is 1 s square, that is 1 plus b times of s square, and this is 2s, this is cs, this is minus bs. So 2 plus c minus b. 2 plus c minus b times of s, and the constant value is 5 minus c plus 5 minus c. So these are the values. Now if you notice, 1 plus b is equal to 0, this is one condition. 2 plus c minus b is equal to 5, this is another condition, and 5 minus c is equal to 3, this is another condition. Got it? Now this is b is equal to minus 1. If b is equal to minus 1, then this is c equal to 2. C equal to 2, here also you can put it 5 minus 2 is equal to 3, this is anyway redundant condition. So you have got the values. So a value is 1, b is minus 1, and c value is plus 2. So these are the partial fraction coefficients. Now you can replace the values here. That is L inverse of 1 by s minus 1 plus b value is minus 1, that is minus s plus 2 divided by s square plus 2s plus 5. For this you have to find out the L inverse value. Got it? So L inverse value for this is straight away e power t plus L inverse of this, actually you will have to find it out. And the denominator, if you notice, this is s plus 1 whole square minus s plus 2 divided by s plus 1 whole square plus 2 square. You can write this way. So that s square plus a square format. Now in the numerator, you have to correspondingly change as per this s plus 1. That means minus you can take it out and then s. So I'll take this as minus of s minus 2. Minus of s minus 2, that is e power t minus, so s minus 2, s plus 1 minus 1. So this is minus 3 divided by s plus 1 whole square plus 2 square. This is how you can write it. Now you can separate it. That is e power t minus s plus 1 divided by s plus 1 whole square plus 2 square plus 3 by s plus 1 whole square plus 2 square. This is how you can write it. Then the answer will be e power t minus e power t into e power minus t into, then this is cos 2t, and then this is, so minus minus will become plus, so plus 3 by 2 e power minus t sin 2t. This is the answer. Got it? Understood or not? The partial fractions format. Any questions on this? Any questions? Okay. So this is how actually you will find out the Laplace transform. One, straight away, if you know the value of the inverse Laplace transform, you will be able to find it out. Another way is apply partial fractions if it is possible to divide into the partial fractions format. And then we will take the other methods also. Find the L inverse of s square by s minus 2 whole cube. Find the L inverse of it. Yes or no? Nobody got it? So in the denominator, this is s minus 2. What I will do is, the numerator I will make s minus 2 plus 2 whole square divided by s minus 2 whole cube. Now, if I take e power 2t, then it will be L inverse of s plus 2 by s cube. So this is e power 2t times of, this is 1 by L inverse of 1 by s square plus 2 by s cube. That's it. So this you will be able to find it out. E power 2t, then 1 by s square, L inverse is t, and this is plus 2 times of 2 factorial t square. So 2 will cancel. So t plus t square into e power 2t. Got it? Sorry, I think so there is a mistake in this. So here actually we left the square. Yeah. Now there is no mistake. So this is e power 2t L inverse of s plus 2 whole square. This is s square plus 4s plus 4 divided by s cube. This is e power 2t L inverse of 1 by s plus 4 by s square plus 4 by s cube. So this is e power 2t times of 1 by s is 1 plus 4 by s square. So this is 4t plus this is 2t square. Yeah. So this is the L inverse value. Got it? Note down one more. Find the L inverse of 1 by s into s plus a whole cube, or sorry, 1 by s into s square plus a square. Anybody else got the same answer? 1 minus cos at by a square. Yeah, that's correct. Anybody else got the same answer? See this. L inverse of 1 by s square plus a square is nothing but 1 by a sin at. This is the L inverse of 1 by s square plus a square. Now, if you want to find out f of s by s, L inverse is nothing but this is integral 0 to t 1 by a sin au du. So this is the principle actually we proved yesterday. So if you take the integral 0 to t f of u du, then the Laplace transform is nothing but division of with s. So in this manner, this is 1 by a times of integral sin au. So this is cos au minus, I think. So cos au divided by a. The upper limit is t and lower limit is 0. Then this is 1 by a square. This is cos at minus 1. So lower limit is 1. Yeah. So minus, if you multiply it, 1 minus cos at divided by a square. This is the L inverse. Got it? So we have used this principle. So in each method actually we were using different methods. So you have to be comfortable with all the methods. This is the integral. Now exactly in the similar manner, so derivatives also we can use it. Find the L inverse of log s plus 1 by s minus 1. Find the L inverse of it. Can somebody tell me what is the answer for it? So this is actually the derivative. So the derivative actually if you take it for log, right? So it will be log s plus 1 minus log s minus 1. The derivative of it is 1 by s plus 1 minus 1 by s minus 1. Now further 1 by s plus 1 and 1 by s minus 1, you will be able to find out the L inverse value, right? So keeping this in mind, the derivative, if you are able to find it out, for the derivative you will be able to find out the inverse of it. So what you can write is t into f of t is nothing but L inverse of minus into d by ds of log of s plus 1 divided by s minus 1. This is how you can write it, correct or not? So yesterday I proved if you take the derivative of it, it is getting multiplied with minus 1 whole power n into t power n. So this is one time derivative. Minus 1 into d by ds is nothing but t multiplication with f of t. That is the L inverse of it. Understood or not? Or do you have any questions on this? Now from this is L inverse. If you want to find it out, minus you can take it out. This is log s plus 1. The derivative, so before derivative, what you can write is log of s plus 1 minus log of s minus 1. So this is minus L inverse of derivative of it is 1 by s plus 1 minus 1 by s minus 1. Then it will be e power t, e power minus t, e power t minus e power minus t. This is nothing but t into f of t, or it implies f of t is nothing but e power t minus e power minus t divided by t. Or this can be written as e power x minus e power minus x divided by 2. You can write as sin ht. So 2 sin ht divided by t. This is the answer. Got it? Any questions on this? What do you mean by consider negative also? Samreen. So I have multiplied with this minus, then only I have written e power t first. Ideally it would have written as e power minus t minus e power t minus half. That minus I have multiplied it. Got it, Samreen? So now convolution theorem. So this is one of the very popular theorem for finding out the inverse Laplace transform and very famous. Convolution theorem, what it says is, if f of s is nothing but Laplace transform of, or f bar of s is equal to Laplace transform of f of t, and a g bar of s is nothing but the Laplace transform of g of t, then L inverse of f bar of s into g bar of s given as integral 0 to t f of u into g of t minus u du. This is what is the convolution theorem states. What it says is, if you know the Laplace inverse of one function and if you know the Laplace inverse of another function also, then the L inverse of f of s into g of s, both the functions multiplication. For that, if you want to find out the L inverse value, that will be given straightforward as integral 0 to t f of u g of t minus u du. Finally, the result of this entire integral is nothing but a function of t, because you are integrating with respect to u and substituting the limits from 0 to t. So that is, finally you will be left with only a function of t. Got it? So this is what is the convolution theorem states. Now in this convolution theorem, you can prove it. So first actually, you find the Laplace transform of this function, that is the inverse method. If you find the Laplace transform of this function, this will be, should be f of s into g of s. It should be the Laplace transform of this one, correct or not? So that is the Laplace transform of integral 0 to t f of u into g of t minus u du. For this, if you want to find out the L inverse, L, that is integral 0 to infinite, integral 0 to t e power minus st into f of u into g of t minus u into du dt. So this is integral 0 to infinite e power minus st f of t dt. So f of t is nothing but 0 to t f of u g of t minus u du. This is the f of t value. E power minus st actually I have brought into picture. Now these are the limits of u. U equal to 0 to u is equal to t. Now these are the limits of t equal to 0 to t equal to infinite. Now this is the first you need to identify the region of integration. So it's a double integral. In this double integral, the region of integration will be, so let us say this is t and this is u, right? So if this is t and this is u, then u varying from 0 to t. So u is varying from 0 to t. So t equal to u line, if you draw it, this is u is equal to t line or t is equal to u line. Now u is varying from 0 to t. This is how actually it is varying. 0 here and t here. Now this value t is varying from 0 to infinite. That means this entire range. So this entire range till infinite. So this is the region of integration. So that is the region of integration. Now with that region of integration, if you change the order of this integration, that is you are doing the integration with respect to u first and then t next. Now what I will do is I will do the integration with respect to t first and then I will do the integration with respect to u next. That is, so these are the u limits and these are the t limits. Now the function is e power minus st f of u into g of t minus u. It will be there as it is. Now you are doing with respect to t first. That's why I'll write dt here and then du. So the limits are varying from, you need to identify the variable limits as in the value of t equal to, or it should be a function of u. So t is a function of u. That means t is the horizontal limit. Now t is equal to u, it is starting with, that is this line, t equal to u to infinite. Correct or not? I hope this is understood. Earlier actually u limits you are taking first. So u is equal to 0 to u is equal to t. That's what you have taken. But now actually we are doing the t limits first. That is t equal to u is this line. From this line to infinite it is the limit. Now the variable limits are fixed. That is t u is equal to t to u is equal to infinite. And the fixed limits are 0 to infinite. That is the maximum range. So that is integral 0 to infinite for the value of u. Now this will be e power minus st f of u into g of t minus u into dt. Now f of u is anyway redundant function because you are doing integration function with respect to t. That means f of u you can take it out. Integral 0 to infinite u equal to then e power f of u into integral t equal to u to infinite, then e power minus st into g of t minus u dt. This is how you can write it. Now this t minus u, let us say I call this as z. T minus u is equal to z. Then at t is equal to u, z is equal to 0. Integral 0 to infinite f of u du. Integral z is equal to 0 to z is equal to infinite. Then this is t is nothing but z plus u. E power minus s z plus u into g of u and dt equal to dz. dz I'll write it. Right? So this is integral 0 to infinite f of u into e power minus sz. Then e power minus su you will take it out. Integral z is equal to 0 to z is equal to infinite e power minus sz into g of z into dz. Now this is as if like it is the Laplace transform, right, of the function g with parameter s. So this is nothing but g of s. Now as it is a g of s, you can take it as it is outside because this is a function of s which can be treated as constant when you are doing the integration with respect to u. So this is, if you notice this one, integral 0 to infinite f of u into e power minus s into du. This is nothing but the Laplace transform of f of s. So this is how you proved that by taking this value, if you take the Laplace transform of it, it is coming out to be the product of f of s into g of s. Got it? Understood or not? Is this understood? Others other than Hitesh? Is this understood to all, or do you have any questions on this? This is straightforward and simple. You have taken RHS and tried proving LHS. In between, you tried changing the limits from one to another. That's it. This is a simple double integration, nothing more than that, just a double integration. Note down this. Note it down. So this base principle actually we will be using rigorously for finding out the Laplace transform. So if you know the Laplace transform inverse of two different functions, then the product function L inverse you can find it out by just integrating 0 to t f of u g of t minus u. That's it. So in one line, I'll just write it here. That is L inverse of f bar of s into g bar of s equal to integral 0 to t f of u into g of t minus u into du. So this is convolution theorem. That's it. Note down one problem based on this. Find the L inverse of s by s square plus a square whole square. Can you find the L inverse of it with the help of convolution theorem? So this can be written as s by s square plus a square into 1 by s square plus a square. This is how you can write it. This is f of s and this is g of s. So it implies g of t or g of u is equal to cos au. Similarly, this one or you can take this f of u is equal to cos au and g of t is equal to 1 by a sin at. So I am treating this as a function of u and this as function of t. Got it? Now here integral 0 to t f of u is cos au into g of t minus u. G of, instead of t, I will have to write t minus u. So this is 1 by a sin a into t minus u du. Or if you want, you can use another variable also, no confusion in it. Call this as z. So z can be replaced with t minus u, that's it. Now, this is the integral value, you need to be finding it out. Now, this is 1 by a integral 0 to t, then this is cos au sin at minus au into cos au into du. So this you can write as 1 by a. This is sin a cos b. Can be written as, how can we write sin a cos b? Sin a plus b plus sin a minus b. Yeah, exactly. So sin a plus b, this is integral 0 to t. So this is 1 by 2 times of sin a plus b. A plus b is at into plus sin a minus b, at minus 2au du. So 1 by 2a, then sin at, you are doing integration with respect to u. This can be treated as constant, that is u sin at plus sin of at minus 2au with respect to u. So integral sin minus cos at minus 2au divided by minus 2a. Upper limit is t, lower limit is 0. This is 1 by 2a. Upper limit, if you substitute it, t sin at minus, so upper limit, this is cos of at. So this minus minus will become plus, yeah, plus cos at divided by 2a minus, the lower limit will be, this value will be anyway 0 and this value will be cos at by 2a. So these two will cancel out. This is 1 by 2a times of t sin at. Cross check it. That's correct only. Yeah. Got it? I hope you understood how we are using convolution theorem to find out the L inverse of a product of two different Laplace transforms. Understood or not? So can you find out the L inverse of, as a simple case, 1 by s square into s plus 2. Can you find out the L inverse of it with the help of convolution theorem and with the help of normal partial fractions, and then try to verify whether the convolution theorem is valid or not, or you simply take 1 by s, don't even take 1 by s square. So 1 by s into s plus 2, apply convolution theorem and then try to find out the L inverse of it. Okay, great. So anybody else got it? So with the help of normal partial fractions, L inverse can be written as s plus 1 minus 1 divided by s plus 1 into s. This can be written as L inverse of 1 by s minus 1 by s plus 1. So this is 1 minus e power minus t. So 1 minus e power minus t is the L inverse value. Now the same thing I will use convolution theorem. Now one function is f of s is equal to 1 by s and g of s is equal to 1 by s plus 1. Now this is, so then f bar g bar, okay. So f of u is nothing but 1 and g of u is nothing but g of z I'll write. So this is e power minus t, right? So I'll take, actually rather than this, right? So if you take the constant in that g function, that will be far easier. So I'll take just inverse of it. So this is g of s, this is f of s. So this is up to you, which you wanted to take it. This is g of u, and this is f of z. Now, so the convolution, so which is nothing but L inverse of f bar of s into g bar of s is equal to, this is integral 0 to t, then f of u is nothing but e power minus t and g of u or g of t minus u. So this is a constant, you can take it as it is 1 du. So this is e power minus t by minus 1, and the upper limit will be t and lower limit will be 0. Then this is minus 1 times of e power minus t minus 1. This is 1 minus e power minus t. If you notice, this is exactly the same thing what we have got. Got it or not? This is the way we use convolution theorem to find out L inverse. This is for the most simplest case, actually we have verified it. For complex functions, as you are not able to use the normal known methods, maybe partial fractions or maybe other methods to find out the L inverse, this convolution theorem will help us a lot to find out the L inverse. That is the only advantage of it. Got it? With the help of convolution theorem, can you find out the L inverse of 1 by s square plus 1 into s square plus 9? Can you find the L inverse of it? S square plus 1 into s square plus 9. This you should be able to solve it. So the way we have done in the previous problem, that is s by s square plus a square whole square I have done. Exactly in the similar manner this follows. Of cos, this sine, that's it. Anybody got it? One is 1 by s square plus 1, another is 1 by s square plus 9. 9 is nothing but 3 square. That is, yeah, I think so, 2 sine 3t minus sine 2t minus 4t by 6. Check it. Anybody else got it? This. So this is L inverse of 1 by s square plus 1. This is nothing but sine t. Similarly, L inverse of 1 by s square plus 3 square, nothing but sine 3t by 3. Right? Now, I call this as E of z is equal to sine z and f of u is equal to 1 by 3 sine 3u. Now, L inverse of the original function s square plus 1 into s square plus 9 For this, if you want to find out L inverse, this value will be integral 0 to t. And f of u is 1 by 3 sin 3u into g of t minus u. G of, that is sin t minus u du. So this is 1 by 3 times of, and then multiply with 2 and divide with 2. So this is 6 times of integral 0 to t. So this is 2 sin 3u sin t minus u. So sin c sin d. So sin c sin d formula you can apply. This is cos a minus b minus cos a plus b. 1 by 6 times of integral 0 to t. This is cos a minus b. This is cos a minus b u minus t minus u. 4u minus t. Cos a minus b minus cos a plus b. Cos a plus b is 2u plus t. For this, you have to apply integral with respect to u. This is 1 by 6 times of, so integral cos with respect to u. So this is, so integral cos is minus sin. Sin 4u minus t divided by 4. Keep this minus here, minus, then cos integral is minus sin 2u plus t divided by 2. So upper limit is t and lower limit is 0. Then this value will be 1 by 6 times of, then minus, if you take it out, this upper limit will be plus. The upper limit is t if you substitute it, sin 3t by 4 minus lower limit if you substitute it, that is u equal to 0, that is sin t. Plus upper limit if substituted, this is sin 3t by 2 minus sin t by 2. So this is how actually you can simplify it. So what is integral cos? Okay, so derivative of sin is cos. Yeah, so integral cos is plus. This is plus, this is plus, but this is minus. Now it should be correct. Got it? So the answer will be, so after the simplification, what you are going to get it is 1 by 8 times of sin t minus 1 by 3 times of sin 3t. This is the answer. Got it? So do you have any questions on the convolution theorem? Any questions on convolution theorem? So this is about finding out the Laplace transforms inverse. So till now actually we have concluded how to find out the Laplace transforms and different theorems that are applicable for finding out the Laplace transforms for complex functions, and the finding out the L inverse for each of the Laplace function, that is, which is in the S domain, to find out the T domain function, which we call as the L inverse finding. So that L inverse we found with the help of the normal theorems what we have used in finding out the Laplace transform. Same thing we will be using in a reverse manner to find out the L inverse value. There is one extra theorem that came into picture, that's what is the convolution theorem, which will be much more applicable for finding out the L inverse value. As long as if you know the product of two different functions L inverse, you will be able to find out the L inverse of the product. Got it? So that is the convolution theorem. So these are the theorems that are there only to find out. Now actually, to summarize, what we have learned is, if given a time domain function, you know how to convert into the frequency domain, that is the S domain function. And then you know, if the function is given in S, you know how to convert back to the original T domain function. But all these things are doing just because of certain purpose is there. That purpose actually we have not touched yet. So we know only the conversion from T to S and S to T. Now, if there is a conversion, obviously it is expected that there has to be a function for it, or there has to be a purpose for it. That purpose is nothing but solving the differential equation. So with the application of Laplace transform, you will be finding out the solution of the Laplace transform, the solution of the differential equations. That is the only application of this Laplace transform. So because it simplifies a normal differential equation into a polynomial equation, which is the S domain function straightforward, you will be able to find out the inverse Laplace transform pretty straightforward and easily, rather than finding out the solution of a differential equation. That is the greatest advantage which we are going to deal with in the next class. That is the application of Laplace transforms for finding out the solutions of the differential equations. Here, any questions on this? So we have just used the tools to do, but real purpose we are going to do it in the next class. So if you have any questions, you can let me know, or else I will log out. Okay, so thank you and good night.